Hello. So I want to just go over reviewing vector addition with you. And in the various forms, when we have it in component form, unit vector form, and magnitude and direction form. So minimize my picture here and begin with that. Okay, so vector addition. This is very easy if, let's say, we have vector A is 2, 3, and vector B in component form is, let's go, -4, 1. Okay. Now we could correspondingly do this as a unit vectors. We could say A is equal to 2i plus 3j, and B is equal to -4i plus j. All right, so be pretty easy to say, oh, A plus B is equal to 2, 3 plus -4, 1. And you know that we add the x components to the x components, so that gives us -2, and the y component added to the y component is a 4. And there is my answer for A plus B in component form. Now I can do the same thing here in unit vector form. I can say that A plus B is 2i plus 3j minus, let me just put that in parentheses, and then I'll say plus -4i plus 1j. Okay, and we can see the nice thing with this way of doing it is we can do algebra now. We can say, we have 2i minus 4i, so that's -2i, and we have 3j plus j, so that becomes plus 4j. So we just follow our rules of algebra, and we have the unit vector form of the answer. And you can see those correspond to the same thing. -2, 4 are the components, so we get -2i plus 4j. So this is very easy. It's also very easy if I said, well, what if I want to do 2a minus b? Okay, so in component form, what does that look like? We're going to take twice 2, 3 plus, or minus, I'm sorry, that's a minus. We're subtracting -4, 1. And what I would do is I would do this in 2 steps. I would say, well, what is twice a? Twice a would be 4, 6, and we're going to subtract -4, 1. So what do we get? We get 4. We look at the x components first. So 4 minus -4 gives me an 8. And then we look at the y components, and so you have a 6 minus 1, and so that will give you a 5. So 2a minus b would be 8, 5. So an x component of 8 and a y component of 5. Now if we do that in unit vector form, we can do the algebra directly. 2 times 2i plus 3j minus -4i plus j. And if you just now follow rules of algebra, you distribute the 2 and you get 4i plus 6j. And then you distribute the negative sign and you get plus 4i minus j. And then you just combine like terms, and it looks like we have 8i, and we have 6j minus j, so we get plus 5j, and we can see that we have the same answer. So doing addition or combinations, this would be called 2 times a is a scalar multiplication of a. We're simply multiplying a by a number, and then we have a subtraction. So combinations of scalar multiplication, addition, and subtraction are all very easy to do when we have component form or unit vector form. It's much more difficult if instead of A and B, let's create two new vectors, C. Let's say that C has a magnitude of 4 and it has an angle, I'll call this theta C equal, actually I'll just write what the angle is at, we'll go with 60 degrees. So it has a magnitude, let me write this out better. Okay, so C has a, I'll write it this way. Magnitude of C is 4 and the direction of C is 60 degrees. And then we'll have a vector D such that the magnitude of D is 6 and its direction we'll say is 100 and we'll go 130 degrees. Okay, so how do we handle this? Well, this would be easy if they were in component form, so let's make them have components, all right? So we can find the components. We can say Cx and Cy. Our Cx will be 4 times the cosine of 60 degrees. We're assuming that all of these angles are relative to the positive x-axis. Okay, so that's in standard position. So the cosine function will give me the x component, and 4 times the sine of 60 degrees will give me the y component. We'll compute those in just a moment. And let's see, dx will end up being 6 times cosine of 130 degrees, and dy is equal to 6 times the sine of 130 degrees. I'm going to pause the video briefly while I compute those, so we're not spending time in the video. Okay, so you can see my results after simply punching those into my calculator. So I can now say vector C is equal to 2.00 comma 3.46 in component form. Vector D is equal to negative 3.86 comma 4.60 in component form, or if I wanted to, I could express those in unit vector form. Okay. Now it's pretty easy, now that I have those in this form, to see that C plus D, let's call this R, because we often talk about the resultant in when we're adding vectors. So R is equal to C plus D. So when we add 2 and 3, negative 3.86, that should end up giving me negative 1.86. So I believe, yes, okay. And then the 4.6 plus 3.6, let me just put that in my calculator real quickly so I don't mess up, plus 3.46. So the y component of the answer should be 8.06. Okay, so that is the component form of my answer. But if the problem starts with magnitudes and directions, usually it will sometimes explicitly say it, but if it doesn't, you should assume that your answer should be given as a magnitude and a direction. Okay, now let's look at the components. This indicates that what we have is an answer that is 1.86 to the left. I'll put a negative on that, and 8.06, this is not quite to scale, in the y direction. So my answer, let me put this in color where you can see an arrow, will point like this. And I need to find this value for theta for the answer, okay? And I need to find the size of the resultant, okay? Well, to get the size of the resultant, this is just, it's a Pythagorean theorem. So the size of the resultant answer, or magnitude, is the square root of 1.86 squared. We talked about dropping the negative sign so that it wouldn't accidentally give us a negative value when we square it. and we put those into the calculator. 1.86 squared plus 8.06 squared, and then you take the square root of that answer, and it looks like we get 8.27, which seems reasonable. Okay, so you can see the hypotenuse is a little bigger than the vertical leg, and I probably made the horizontal leg a little bit too long in the picture. So that's a reasonable answer, and if it's so that is probably correct. And then if we want to get the theta value, all right, we would start with that the tangent of theta is equal to negative 1.86. Oh, I am sorry, I put the x first, a common mistake. It's opposite over adjacent, or the y over the x. So this should be 8.06 over negative 1.86. Okay. Now, this is a quadrant 2 answer, so we need to use caution. So the angle will be the inverse tangent of the ratio, 8.06 over negative 1.86. But we have to add 180, we're in degrees, so add 180 degrees to it to get the answer. All right, and so just type that in very quickly into my calculator. And negative 1.86. So the first part of this is negative 77.0 degrees when rounded, but clearly that's exactly wrong. That would be pointing into the fourth quadrant. So when I add 180 to it, the answer comes out to be correctly pointing at 102.99. I should probably call that 103 degrees. Okay, so the magnitude of the answer is 8.27, and the direction of the answer is 1.03. Remember, if that had been in a quadrant 1 or quadrant 4, I wouldn't need to make any adjustments to the angle, but if it's quadrant 2 or quadrant 3, you need to add 180 degrees to your answer to get the right answer. So that's how you do vector addition when you have a magnitude and direction of two vectors given. But you can see, hopefully in this little lesson, it's much easier to work with components. And so that's why when we have magnitude and direction, we put it into component form, and then we use our basic trigonometry to put it back into the magnitude and direction form. But the translation steps are the hardest steps. The addition steps are quite easy. So we, in order to do addition, we ultimately do need to have components in order to do the addition.